Introduction to Thermodynamics. Thermodynamics is a branch of physical science that deals with the relationships between heat, work, temperature, and energy. It helps us understand how energy is transferred during physical and chemical changes. Whether it's running an engine, boiling water, or chemical reactions, thermodynamics helps explain how energy behaves in all these processes. Important terms: heat and work. Heat is the energy that flows due to a temperature difference. It always flows from a hot object to a cold one. Work is the energy transferred when a force moves an object. In thermodynamics, work is usually done by expanding gases or other physical changes in the system. Both heat and work are forms of energy transfer. They are not stored in a system but are observed during changes. The four laws of thermodynamics. Zeroth law: if system A is in thermal equilibrium with system B, and system B is in equilibrium with system C, then A and C are also in thermal equilibrium. This forms the basis of temperature measurement. First law: energy can neither be created nor destroyed. It can only change forms. This is also known as the law of conservation of energy. In thermodynamics, it is expressed as delta U equals Q, W, where delta U equals change in internal energy, Q equals heat added, W equals work done by the system. Second law: in any spontaneous process, the total entropy of the universe increases. Heat flows from hot to cold objects, and not the other way around naturally. Third law: as the temperature of a perfect crystal approaches absolute zero, 0 K, its entropy approaches zero. This means there is perfect order at 0 Kelvin. System and surroundings. In thermodynamics, we divide the universe into two parts. System, the part we are studying, e.g., gas in a cylinder. Surroundings, everything outside the system. Types of systems. Open system, both matter and energy can be exchanged, e.g., open cup of tea. Closed system, only energy can be exchanged, not matter, e.g., sealed bottle in sunlight. Isolated system, neither matter nor energy is exchanged, e.g., thermos flask. Enthalpy H. Enthalpy is the total heat content of a system at constant pressure. It is denoted by the symbol H. The change in enthalpy delta H tells us how much heat is absorbed or released during a reaction. Formula: delta H equals H products H reactants. If delta H is positive, right pointing arrow, heat is absorbed, endothermic. If delta H is negative, right pointing arrow, heat is released, exothermic. It is used in reactions and phase changes like melting, boiling, etc. Entropy S. Entropy is a measure of disorder or randomness in a system. The second law of thermodynamics is based on entropy, which says that the total entropy of the universe always increases in any natural process. If delta S greater than 0, right pointing arrow, process is spontaneous. If delta S less than 0, right pointing arrow, process is non-spontaneous. A more disordered state has higher entropy, like gas compared to liquid. Gibbs free energy G. Gibbs free energy helps predict whether a reaction will occur spontaneously. Formula: delta G equals delta H, T delta S, where delta G equals change in free energy, delta H equals change in enthalpy, T equals temperature in Kelvin, delta S equals change in entropy. If delta G less than 0, right pointing arrow, reaction is spontaneous. If delta G greater than 0, right pointing arrow, reaction is non-spontaneous. If delta G equals 0, right pointing arrow, reaction is at equilibrium. This concept is very useful in physical chemistry and biochemistry. Thank you so much for watching. Agar aapke thermodynamics ka ye video